You can use an introduction. Today we have another interesting sessions, mostly hands-on sessions and demonstration of various simulator platforms and robotic platforms. So in the morning sessions are handled by the scholars and students, and we'll have a detailed demonstration of the SIBO platform and RVS platform, and now robot and also rewards. Yes. So in the first session of the first talk from the session is by Mr. Kamal Basha, and who is a PhD scholar in the Department of Computational Intelligence. He has been working in the DRDO project for the last 2 years. And as a part of that, I gave a glimpse in the yesterday session. As a part of the project, we have been developing some synthetic sonar simulator platform. Using that, we generated S3 simulator, which is one of the S3 simulator, which is a established and simulator data set. So there is no such simulator data set is existing. Only the real sonar data set, when we started looking, it is very minimal, around 300 data only. So sonar images has certain characteristic. It should be collecting in such a way that the quality matters and the angle matters and the height at which the sonar image is taken matters. So with all these specifications, then only we can analyze and study for our image analysis, right? So whatever we were trying to collect, also were lacking this kind of quality. Some are very low quality images, and some were very unclear to distinguish the class. So all this have urged us to develop a new set of sonar images where we can develop some sort of classes like ship class, plane class, seabed class, mine class, so on and so forth. So a detailed analysis and explanation of this particular data set that we have developed will be given by Mr. Kamal Basha. Welcome, Kamal, for an interesting session. That is one data set from Chinese people. And it has very minimal data. With that, we cannot train any deep learning model. Some of them are available, but it's low quality, not useful for many studies. So we made from scratch, except of the amount of data, around 20,000, 30,000 of data now.
Hi all. Very good. I'm Kamal Basha, working as a junior research fellow for the Director of Program Training. And I was thinking about so the number of accessibility ratio to sonar like sonar domain. In that project, we have around the 4 objectives. And the first objective is to develop the data set. So this is our objective. And I will show you a small demonstration how we develop the data set. So before going to the data set, today we will see a small intro about the sonar images. As we know, the present trend is going in different manner. In particular to computer vision, PLM, LLM, diffusion models, GAN. They're developing the models with data, but still some domain exists, lack of data in collecting the data. So we need to know the importance of the data. All right. So I will show first. Let me start with the question. So what is the fuel of AML application? Let's be interactive. You can respond whatever the answers to your mind. Yes, sir. That's the right question. Data. Data is the fuel, right? So if you are developing some AI application, for example, a visual-based application, so what will be your thought process? Consider you are working in an Amazon. So your job is to develop a product, a vision product. So what will be
how much inventory do we have to store the product? What is the people that makes that product? What's the target price? Who wants it? Simple as content, that's not content.
Apple and Mango? Simple classification product you are going to deliver. So what will be the process end to end? As image processing good? Training model is very important. Yeah, okay. That will be under the optimization and training. Any other? Let me give you again. The basic jar is dataset. Dataset is very important to develop a application. For a dataset, then data processing will be there, model training and deployment. So all these processes will be included in an AI application. In generic scenario, in normal scenarios, if you build an AI product like companies, for example, Amazon, they have different products like Alexa and Ring security cam. Have you heard about those products? So to develop that, it's really working well. To develop that product, they are spending huge amount of money in collecting the data and pre-processing the data. All right. So this is the Ring device. The Ring device. This product, what it will do is, it will be fit outside the outdoor, and this is the boundary region. In this region, if one car comes parked in some other car comes, or a courier parcel comes into this region, this will trigger to the customer. So the customer will know, or something I have received like that. So in your thought process, you have developed some product like this. So what is the challenge in this? Could you point some 2, 3 challenges? Now the product is ready. What are the challenges? Here they have developed with the data. They have data as ma'am said, image processing done, model training done, deployment done, application done. Now we have deployed this product successfully. Now what are the challenges we can face in this? Yeah, okay, some unidentified objects. Okay. Unusual happens. Like, for example, in some cases, tree will be there. It is not static, it's dynamic. So each and every time if passes trigger to the customer, then he will get annoyed. Okay, unusual things. Next. Okay, some random animals will go each and every time if you go triggers. So these are the problems. So where to fix these problems? We cannot fix this problem in model training or deployment. We should fix this problem in the data part itself, where you collect the data, where you process the data. So this is how the data part is very important, and it is very expensive. Why I quoted this example is the collection of data is very expensive in generic scenario. Now we'll go to the Sonar domain. So this is how the Sonar image, Sonar collection of Sonar image works. As yesterday, Jayakant sir said.
What you do, you cannot solve the study case. So, you cannot collect all the data. Once I find out some issue.
Yes, based on that issue, we need to collect the data collection part. We should improve, and the training part.
But no matter what you do, some cases will not.
Yeah, it will come under trial and error. So, okay, we have facing some issue means then we need to fix from the data part. Yes, it's
correct more than you to replace.
yes, correct. So now we come to the sonar image. Sonar image, like Jayakant sir yesterday said, emitter and receiver, like LiDAR and radar, same in sonar, but it's in underwater. It is in underwater. So in underwater, signals will be emitted from the transducer and then the detector. After the detection, we will get the image of the object. So here, so this is the working of the sonar images. This is how the images is captured. And here we have some issues. The first issue is, for example, if we want to develop some AI tool, AI application, okay, we plan to go to the real scenario and collect the data. First issue is we need to purchase the sonar device. It's very expensive. And the next, we need to spot the specific ocean, like Indian Ocean or Bay of Bengal or Arabian Sea. So where is the ocean? And the next, okay, we spotted the ocean, we purchased the sonar device in lakhs, and then we went to the spot. Now we need to capture some image, right? In real scenario, okay, for a demonstration purpose, you can take tiny objects like tire and trash and then put into the particular area and capture. But in real cases, study is what says shipwrecks, finding the shipwrecks, recent incidents, accidents happening, and they are trying with experts, and then they are implementing sonar device. We need to find the shipwrecks. So either one, we need to demolish a good ship and put it the object at the location, or else we need to put the scrap. Then again, we need to find the experts and then manpower cost. Every cost is there. Okay, we have done some experiment. Sonar device is ready, and then ship is ready. We now going to capture the object. So in that, okay, there are two possibilities of two issues. One is the high quality data and the low quality data. We got the data, but we have some issues. We may get the low quality data because in water medium we cannot expect the clear medium as in air. There are so many noises will be there. Based on the salinity, turbidity, and temperature, the images it will affect the image. So we cannot expect 100 images are in high quality. There may be mixture of low and high. Okay, we got some high quality now. Then what's the issue? We got some high quality images. Then what's the issue?
Many images, right?
Yes, many images. Many images where there should be different variants so that we can deploy the model without issue of overfit. So yes, although we have these many processes like purchasing sonar device, making the shipwreck into the particular region, and then capturing the device, and then although we capture images, we got very few images with diversity. With this, we cannot develop a good AI model. So this is where researcher is working on different aspects. So in this approach, our approaches is, so these are the sonar image features. So in generic scenario, like RBG images, you can identify the object. So some colors will be there, background will be there, and this is a human, this is a plane. But in sonar images, it is little bit different. So in each and every sonar images, this is the seabed region will be there, but this will not be in normal images. Like image and dataset, if you see, there are a variety in backgrounds, but in sonar images, seabed will be similar in all scenarios. There may be minute variation like gravel, seabed, and sand. So this you cannot identify. There will be not huge variations in that. Seabed will be always present in the sonar image, and then the body part we call it as a highlight. And then the shadow, this is the shadow part. In some scenarios, and most of the scenarios, how the operator will find the object is this highlight part will not be clearly visible. Only the shadow part will be visible. So the operator has to find by locating the shadow part alone. So this is about the sonar images. Highlight is the body, structure of the body, structure of the object. No, this is a real sonar image. This is the plane. Plane, and the structure of the body object is called as highlight. Yes, sound correct.
So there will be more noise compared to
More number of noise will be there. Variation of noise. That is the one of the main issue. Yeah, low resolution noise in real images. That's why the real quality images is in real world it's still that. In your data set, provide mileage to some good quality images. And you can model use that. Any since you like low quality, in our data, we are implementing the noise. We are integrating the noise. Preventing the noise as well. So that it will learn the pattern. So our proposed solution is the S3 simulator data set. And in this data set, we are combining three tools. The one is segment editing model, and next is CAD tool, and then gazebo simulator. Have anyone used the segment anything model here? Segment anything model, or any idea about CAD tools? AutoCAD.
All are undergraduate level.
Yes. Yes. Yeah, tell me, no problem. Okay, we are integrating three tools. And at the end, I will show how it works. Now we will go for the gazebo tutorial. Before that, I will give a clip. So this is our silhouette images. From the silhouette images, we need to segment the objects. So here, our class is ship, plane, and mine. And this is with the help of segment anything model, we are segmenting the objects. And then with the help of self-CAD, we are developing from 2D images. Segmented objects will be in 2D. Then we need to convert 3D to deploy in the gazebo. For that purpose, we are using the self-CAD. Once the 3D model is obtained, then we are using the gazebo simulator. And then some computational imaging techniques are applied and mimicking the as similar to the real world sonar.
So what is mean by real world?
Real world sonar images.
What is implications for the
These are the real world sonar images, publicly available images. And we are simulating an image similar to this real world sonar image. But different is we are not going to the ocean. We are not doing any object rendering there, or not in the field, but we are doing the simulator work.
How is getting the base image?
Publicly, there are 20 plane images available and 100 ship images available. Those are the only images available at present. So those are our base images. Like
What about different cases, different objects inside you, so different kind of noise? How do you do that?
as for noise, we are replacing spectral noise is familiar for the ocean. Spectral noise.
I mean, because of different construction.
That is another problem statement.
Different things lying on the seabed.
Yeah, correct. Okay. As far as seabed, we are. I will show the gazebo. That we will find the different type of seabed, but still the problem exists. We are minimizing the problem, but still it didn't complete. Still, we have some issues.
Using already existing data set as your base setup. So that you are not.
No, we are not. We are not using like in GAN diffusion model. We can use and then manipulate, but here we are not using. That is separate. With reference to that, we are developing new from scratch.
Just developing new things.
Yes. I will show the sample images, then you will get an idea.
So the surely it's better you come close to the laptop and speak so that the audio will be good. You have to stand here and someone of language.
So here is our gazebo user interface. So if you want to install the gazebo, you can install in Linux. But if you're having Windows system, Windows OS, then you can using the WSL. Windows subsystem for Linux is there. You can use that one and then install the gazebo. So this is the user interface. These are some physics parameters like gravity, magnetic field, solver, and then atmosphere. So all these based on your objective, you can we can try and see. So some of the sample given in the gazebo are box, sphere, and cylinder. And if you want to make customized 3D model, it is limited. We cannot create any 3D model here. That's why we are using self-CAD. That I will show next. So for the basic purpose, why we need simulator?
Yeah, we decided to build a particular model. Instead of manufacturing it, software manufacturing it, and then integrating it for the builder.
Yeah. Yes, good. Yes, correct. Cost effective and then time. And the next simulator will act as a bridge between the theory and the reality. Like yesterday, we saw some theory sessions, right?
Yeah.
So we'll see. For example, if you want to make a robot car like that, and there is a huge cost in it, you need to purchase something. So here in Gazebo, let's see. I'm showing we need some accurate measurements. So don't expect accurate measurement here. For sample purpose, I am showing here. In the model editor, uh, consider this as a chassis, and here are some options to rescale it. And I need wheels now. Can rotate. Okay, I got the wheel ready. So now 4 wheels should be there. I can copy that, you can do later. Now I will. So now the object is ready. Now we need to link between the objects. As yesterday Jayakant sir said, links, joins, you would have here, right? In theory. So now we will link the object. So here is the link. And these options you would have seen yesterday theory session. Fixed, revolve, screw. So all these will be there. Now we will link the between the two objects. And there are positions, relative phases. So all these parameters are there. Then you can adjust the material. Like for example, here in the density, you can choose the material, what material you want, iron or brass or aluminum. So these parameters are there in Gazebo. You can explore, and then you need to save the model. Then you can fix the parameters, the physics parameters like kinematics, all those things you can fix here, and then you can start the simulation. But this will not work because I didn't fix 4-wheel. Now we get into our work. So how we develop the dataset with this simulator. And there are some noisy cameras are there. You can fix in the robots and you can simulate. So here we utilize the one model called Sand Island. So to replicate the seabed, we consider this as a one of the seabed, and then this as one, like this. This is how we are getting different types of seabed. We are assume this as seabed. Now the 3D developed model, that is, these are all models which we develop. So this is the aircraft, broken aircraft. So here in real scenario, like as we said before, we find the ocean, we got the sonar device, and then we place the object. In real scenario, you can take this, capture this different orientation you can do, but like normal images. But in underwater, you cannot do. You got a shipwreck there, and how you will rotate the shipwreck? That's the problem. So here you can make a different type of images. Here there is a capture option and video option. Once after the video recording, you can take images from the video. So here the object rendering can be done using this rotation option. Different orientation you can move and then take images. This is for the object rendering. And then another part is shadow. As I said before, the shadow gives the more information in, so particular to the sonar image domain. So how we control that shadow is in the lights with the help of sun. Like as in yesterday's session, you would have seen roll, pitch, yeah, in theory, right? So with those options, we can control the shadow of the object. Roll, pitch, and yeah. So with these parameters, we adjust one is object rendering and different type of shadow. in real world scenario, if you are collecting the data, the shadow will be in dynamic based on the sonar position, the shadow changes. So those things we can bring it to the simulator world. So next we are on, after collecting these images from the simulator world, we are applying some computational imaging techniques. So this is how, real, this is the real sonar image of plane, and this is our simulated images. We can change the orientation, we can change the shadow effects, and instead of here they are having in real world, they are collected with a huge amount of expense, they are collected around 100, 200. But here we can develop like thousands, more than thousands you can collect. This is for particular single plane, but there are more number of plane you can explore. And this is the navigator zone. In sonar images, there are different types of sonar, like forward-looking sonar, side scan sonar, multi-beam sonar. So here we took a side scan sonar. So side scan sonar for identifying the object, and then seabed mapping for all those side scan sonar will be helpful. So this is the real image of the ship, and this blind spot is called the navigator zone. This is our simulated images. And the next, another issue is in real sonar images, the object will not be looked as a plane. This is the real object of plane. But based on the shadow, we can identify, oh, this is plane. Same in the simulator platform, we can do. Look, this is a kind of uh, a kind of stick, but shadow shows this is the plane. Similar to here. It's a kind of stick, but shadow shows it's plane. So this kind of efforts we can bring into the Zibo simulator. And yes, correct. Yeah, correct. Yeah, here what we'll do is we will run the simulator platform. It will run in different orientations. From the video, no, we will not do augmentation. We will record the video in the simulation platform. While recording the video at 2 minutes, 3 minutes, 4 minutes, from that video we will extract the images. So our count will be increased. Images, correct. So this is a end-to-end process, like from the segmenting model to the final image. This is segment anything model. In previous days, what we used to do is we used to annotate, like in bounding box, in polygon, and then train a model segment. So here it's an open source. Even you can explore the segment anything model. You can easily segment with a prompt. So silhouette images of planes. So here I have chosen the warplane. Why silhouette images? Self-CAD will accept only silhouette images. So that's why I chose this. So here we are using the prompt. Once I got the images, then self-CAD. Self-CAD, where we will use self-CAD is, for example, if you are, have anyone noticed the fire water service line? In every floor will be there, fire water service line. So before in production, like before deploying, the engineer has to check whether this is each and every detail. Like there will be a GA drawing, there will be a detailed drawing in that what type of material it is, how long it will withstand, and where should the bend come, how much degree should bend come. All these things will be in the designing plan. So in the designing plan, the engineer have to do design first, and then he will send to the manufacturer. So that's why the CAD tool comes into the picture. There are so many CAD tools like AutoCAD Fusion is there, Maya is there. So here we use the self-CAD. Self-CAD, why is the remaining CAD tools and all you have to make precisely. If we start each and every object from the scratch, we need to know about the details. We need to go to the designing drawing. We need to get the details. It's again time consumption. We are using that self-CAD because we can directly make from 2D to 3D object. So that's why we use the self-CAD here. Our segmented image. Then we are bringing to 3D model. There also some parameters are there. Then we deploy the 3D model to the gazebo simulator. And we are collecting the images from the simulator. After the object rendering, and shadow rendering. Once the image is collected, next we go to the computational imaging techniques. So these are the sample images of our dataset. So this is all about our first objective from our project. Any questions? There are different varieties of sonar images. In this, one is color mapped. In the color mapped, we see the real world sonar device. They are giving this kind of yellowish images. And then grayscale, and then with the nadir zone. So there are three different categories. One is grayscale, color map, and then with the nadir zone. Ship hull will be like this. Sonar device will be fixed in between these hulls. So the blind spot will be at the bottom of the ship. So that spot will not cover in the sonar image. So that part is this one. So we are simulating that part as well. Yes, sir. And the bottom of the ship, it will be in this direction. So one sonar fixed in this side, another one. This is no, no, no. That is called side scan sonar. It will be fixed on the side of the ship hull at the bottom. It will emit the rays and then receive the rays. Uh, Inside the sea, the deep ocean is very dark. But from the after the sonar image, once the like similar yesterday you said right, receiver, emitter, and receiver. After emitting the sound signal, it will hit the object, and the backside of the object it is called as a shadow. After receiving, our that image process will be in style like the visible object will be in, that is called the highlight part, and the not the background of the visible object is shadow part. So after hitting the process only, we will get this shadow and highlight. But in real world also, that's the same pattern. This is how sonar works. No, no, both same. Shadow rendering for giving the different type of variants in the for in real world. If you want to collect means there will be one shadow will be on one side. In simulator world, we can no. I am controlling the sun here. Source of light is sun. Like the roll, yeah, pitch method. I am controlling the sun. From that sun, I am collecting the different type of shadow for the same object. So the diversity, number of images not in the same pattern, but different shadows condition. So the diversity will increase the data set. Any questions? First issue is we don't have a real data. Then we need to evaluate, right? So,
but even after the regular, it's still kind of no possible.
here in this domain, still there are so many problems are there. One is, as I said, the data in this data set, as had pointed before, due to the variations of the sea temperature, sea salinity,
Yes.
and then the wave, the image may differ. So that is not still that is yet to develop. So that is one of the issues still remaining in this domain. And then compared to the normal images, here seabed is similar. The model will learn sometimes seabed as a plane. It doesn't know because each and every object plane, the seabed will be present. There is no difference in the seabed. So these are still some problems are there in this sonar industry. Okay. If you have any doubt, you can come to our lab. Thank you.